the presenter's screen. Start sharing my screen. Presenter. Share keyboard and mouse with nobody. Audio. Microphone. Speaker. Good. That's smart. Check, 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 check. Hello, 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 hello. Okay, that's peaking. Very good. Right. Line. I have nobody in there yet. It seems to be working. With that guy. Check, 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 check. That guy's alive. All right. Whatever. Hello, hello, check, check. Check, 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 check. So it's the channel, not the mic. Check, 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 check. Check, 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 check. That works. Check, 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 check. Double check. Triple check. Quadruple check. Hey there, how you doing? Yeah, it is. Trying to get it all to work. I have two students that are, I used to go to meetings.
It was like 3:30 on the airplane.
looks good on paper, but then you're gonna find good discount value.
Well, yeah, the discount value is the actual problem.
Yeah, there's a little problem there, you know? That's my class, I actually talk about that. Sell. Companies I work for, I work for a lot of startup companies. There's two cells, one with a little tiny number in it, and one with a really big number in it. And you multiply them together, and that's going to be your revenues, you know? I worked on a project in Mexico for 5 years, and the entire time those numbers were, right? It was actually 5 years over a 7-year span. And it's my story of little number times the big number.
Yeah.
Will get you.
It will, absolutely.
Yeah. You look at things like PERT, and you look at in the estimates.
Oh, yeah.
Looks good.
So we're gonna pretend like the revenue streams and the cost streams are known. They are stochastic. They're known. And oh, by the way, everybody knows they discount.
Yeah. That's interesting. I didn't know that you covered all that. That's a lot of what you do.
Well, you do the same thing except more applied to actual processes. I do the math behind it. You get good at solving.
Yeah.
That's the other one. They get good at
Oh,
Excel.
yeah. That's
The stats talks.
Yeah.
Yeah, we go through multiple regression and to linear probability models. That's as far as we go.
Pretty dangerous thing if you have that.
Yeah, guaranteed if you're putting it in Excel, you're gonna get it wrong. You screw with the universe.
The thing about that hammer is
Well,
you can find errors anywhere you want without them.
Yes, absolutely.
Well, here, just in this class, I use, I make sure people can run a company, right? I'm using the simulation for production facility. I make sure people can look for what's the revenue of that company and why are you so you don't let anybody escape that. Can't run a company. Seriously, I try to do it.
I do one problem where the information is in the divisions, right? So you can find, the only place you can find total revenue is from sales. And resource costs you have to find, you've got to find it either from facilities or from shipping and receiving or from personnel. You get all of the, and now they've got to calculate, they got to figure out how to calculate what the profit is. They've got to disentangle it, maximize the profit.
Business.
Yeah, actually, as opposed to the numbers that just given to you out of the book, plugging into Excel.
I know you do. Pragmatic. It's dangerous. Yeah, I mean, you look at things stochastically, the probabilistically, you can at least handle null distribution binomial.
Yeah.
If I can get my data analytics undergrad class for the next 3 years, you understand that. Just look at everything that way. Because usually, if you're wrong, you're still right. I mean, your average is getting so narrow, you're fine, you know. But yeah, it's just everything from classes that way. When you see a problem at work, it's probably because nobody's treating it that way. It's like you have a range around here, you know. I usually bring that up to it first.
Oh yeah.
How sure can you be with your estimates? I got to connect here. I guess
I will let you connect.
See my students.
I saw you plugging weird stuff in.
Yeah, I have lights running.
I would
audio boxes.
I would harass you for it.
All right. Okay, have a good class. Nobody showed up yet, I don't think. Where's my glasses? Ah. Got my glasses. Stephanie, how are you doing with my floor?
So I don't know if I just have this beginner came up.
Yeah.
In the negative still, like I'm going and it doesn't record if I'm in the negative. So.
Have you haven't got through yet?
No.
Because I took a look, right? You were close, like 23. That was 2 weeks ago.
Right, but in the sandbox, it's like.
It's fine. You can use either one. If you pass it, you pass it. I'm gonna make anybody.
I'm like still trying. Like I want to get 25. Right.
If you have 24 and 3, I might let you go. But still, I find that it's really an accomplishment thing anyway to walk away and say I beat it. You know. That's that's a big thing out of this course is to feel like you can run the company. as Ludwig was saying, that it's different almost every time you run it. Sometimes you get a good string going. Sometimes you're working hard and you're not getting any good quotes or anything to bid on.
Here's what I'll tell you. If you see hunting pants, make them. Hunting pants are the single best product out there. Materials like 40 cents.
Spickles, isn't it? Call this with an H. Happens. So, okay. Okay. Nicholas is our remote. Alvin's place. Oh, so the two Mount employees, where are they? Oh. myself mic'd here. We have at least one Nick on the other side that can't speak. He's on a bus, but I hope he can listen, and I hope he can see the screen, because I tried recording last week, and I got some weird results. The first half was completely black, just a black screen. And then you had the voice recording, but it didn't have the video, and I wanted to post that as helps, because each time you do it, it gets a little bit more refined and more refined, and actually I kind of liked what went on, the description of the statistics in the second half of the class last week. So just to remind ourselves of where we are, we're on week 5 of 6. It's a little bit of a brief session that we have going here relative to the ones that are 8 weeks during the normal semester. So I've definitely noticed the difference myself. There's supposed to be 6 quizzes. I'm going to cut that back to 4. So things are going to come kind of, I'm going to try to give you extra time here through the end of the session, which technically ends like Friday of the week of the 12th, right? I think technically it's either the Friday or the Saturday there, but I did give you till like Saturday night to get one of the assignments. So there's 2, let's work backwards. There's 2 big things happening at the end. There's a final exam and there is a final paper, which we've been talking about. I'm going to spend a little bit of time on wrapping up the Excel for the paper, and there are instructions and rubrics for it. I've expressed them here in class, so not to be a shock, or I've basically given you the format to use. The soft side of things that you have to fill in is up to you. I mean, that's where the premise is really important here, that you were sent out from an executive team from Kibbe and Strand, and they almost forgot about you. You've gone out there for 30 weeks, cost them almost $500,000 to pull this thing off. All right? And they're expecting the cost benefit of this should be, something pretty good. In reality, we would probably add some like 3 zeros at the end of all the numbers that actually happen inside the simulation. But the premise is that it's not a simulation. This really happened, okay? And that is how you're going to write the report. It's an exercise in business writing, okay? So I had an interesting chat with Ludwig in advance of starting tonight. I had to talk about other kind of writing that you're doing at the MBA level, covers, research, MLA type, research formatted, references, citations, etc., right? And all that. This is different. This is an experiential thing that is a method of expressing the success that you had in clear terms, making sure that you kept a good score. So I'm going to kind of look in there. I'm going to make sure what you want to be talking about, you basically walked in there almost no help. You had the student manual, and you had people, staff, personnel at the company helping out as you were going along there, but nobody had any answers because the big management had all walked off, right? Amanda, as much as she could help, she did. She got you started, but she didn't get much further than that. She's familiar with everything that happens on each section of the five sections of the floor, but the premise here is paramount, that you write and keep the voice. You keep a professional voice and use professional standards and whatever. I can give you references to certain things that if you are already, feel yourself as a pretty good writer, you can get away with. But if you have sort of choppy writing, this is a chance to practice, okay? One thing that we forget about in academia, we have such an appetite, and we're accomplishing things so fast, chapter by chapter. Some things take repetitive practice. In fact, that's really the truth of learning, is it's at least the see one, do one, teach one effect. And so in learning, I think I started adopting this probably when I started the MBA program I did a long time ago, is if I'm going to really learn something, can I teach it back out again, right? So your experience here, the reason why I created the premise I did is you're going to try to gather up carefully all the discoveries that you made that led to success. And there's more of them than you normally think of, okay, usually. You have to remember, every little move you made that you said, oh, I wish I didn't do that, that's a discovery. Or every time you had a good feeling and something good happened and you can explain it, you have to substantiate the information that you have. And we boil it down into the worksheet, the analysis sheet of Excel, okay? So we've gone heavily into the left side, the profitability side of it. And I'm just going to go over quickly the schedule side of this, one of the quizzes is going to be based on things we've discussed in the class about how they really work on the floor versus what was going on in the student manual. So remember to think about that a little bit. All right. So if everybody can pop their Excel file open, what I want to do is I'm not going to spend a lot of time on this tonight. I'm going to get out, so I might drive somewhere here. Which pocket was it in? Uh-oh, what did I do with it? I don't feel it in there. Maybe I have it in a different pocket somewhere. All right. So I'm just going to use it to pop open a generic Excel sheet here. Really? It's not in there. That's weird. There it is. I found it. I have too many things in my pocket. Okay. So if everybody pops that open, and then I keep saying we're going to load that up into a daily submit point on the e-class, but we run out of time or whatever. Tonight we'll try to remember to do it. Okay, so our Kibbe strand file, if you remember this, let me push it down a little bit. Let me go back to 100% viewing on this. All right, so we worked really heavily on the left side of this. And for those playing at home, I have to move to the other computer. This is going to be interesting. Hold on. That's a skill I have to develop. Remember to use the right computer. That is not making me happy. Technology. All right. Okay, let's see. Okay, so now people here can see the same thing Nick is seeing on his ride. Nick, if you can hear me, just let me know. Okay.
Yeah, I can hear you fine.
Into the future, you're in next week's session instead of tonight's. That's okay. Found you. All right, we're just getting going here anyway. So what I'm doing is I'm popping up the Excel file that we worked on last week. Open. Okay, there we go. Now everybody's on the same page, including me. All right. So when we worked on this file, we worked on the left-hand side. That was all the profitability. We took all the primitive information and we created 3 sections that were lightly yellow colored or light yellow colored that showed interim subtotals of 3 major costs, just to remind us what we have in here. And we were excluding, like one major one would be labor. We didn't allocate labor across all the contracts. If you look at it, it will average out to a certain extent if you're moving people around and whatnot. So that would be, as we started to discuss what goes into your final report, one of the things is what
what about, say, labor as a next step in your conclusions? The conclusion of your paper will have next steps, lessons learned, and next steps. Okay, it's good to delineate them again. Papers can be slightly redundant to remind people, what is a conclusion, what is an executive summary, really. If you do an MLA paper, you might have an abstract, an introduction, and a conclusion. And in some sense, you're stating similar things, slightly different context, okay? So in our paper, we're going to have an executive, this is business writing, not MLA research type writing. So we're going to have an executive summary that puts out all the major points that executive management is drumming their fingers on the table, waiting to hear back from you. Did this experiment that we had with this new employee work out or not? All right. I try to set the setting. This is the truth. I mean, this is how it works in real life. The motivation there is, somebody signed the bottom line to put a $500,000 project together to try to straighten something out, and you're trying to bring back the cost benefit to this. You're trying to bring the benefit back to the cost. Your discoveries. All right. How would we do this? Is, as I said, if you look at the Kibbe-Strand environment, you probably add a comma and 3 zeros to the end of all those numbers that you have for 30 weeks, and that would be a small company. I mean, that would be considered a small company. Certainly by head count, at most, what are you going to have there? 12 or 15 people at very, very, very most. That's considered a very small company. In the parlance of small and medium companies, you're talking about small and medium go up to 1,000 employees, roughly. Just say as a benchmark as to when you see the word SME. Is everybody familiar with that? SME? You see SME? It's a very common term, and for different regulations and types of things, a small company is up to 1,000 people, which is not small. Okay. Just checking with the Knicks. If you can let me know that you hear me. It looks like my mic's working, but I got to make sure with you all that it is actually working. And you can see my
all good
video.
on this side.
I hear Nick M. Okay, got it. Very good. Okay. All right. So going back in here, I'm reminding you a little bit of put this over here. You can end up building out analysis for 12 different garments. The first 5 are the ones that you're stuffed with when you first enter into Kibbe-Strand land, Okay. And we were, hopefully everybody tracked last week. I have the audio, but not the video. The video didn't catch last week for some reason, but I do have the audio for what we went through for all this. And it is up on YouTube, and I can send you the link if you want to listen to that. One suggestion that I'm going to have is, in the world of professionalism and offering how to become very efficient, is I'm going to show you something really quick here. Here's a tool. There's 2 things I tend to talk about in my classes are things that I use all the time. Is the Snagit, which I showed last week, which is great for taking screenshots. It gets much beyond what you can get with the built-in snipping tool from Windows 10 and whatever it is for the Mac, the command, whatever it is. Maybe even a couple of different things. But the other thing is, I have mentioned about, especially Excel is very, very supported in YouTube. The community is really strong for YouTube. If you have a problem, YouTube is a great place. So when I offer these YouTubes, I want to show you something here that if you go to your browser and you go to settings, no, I lied. If you go to your browser, get yourself a new window, and you look for video speed controller. I mean, I'm telling you about this because it helps me in my professional world of what I do to, catch up on, say, things that are on YouTube and whatever. You can go, depending on whatever browser you have, just look for, the name of the product is Video Speed Controller. It's very generic sounding, but that's the name of it, okay? And Video Speed Controller, I have it added already in my browser, so that says my option is to remove it. For you, it would say add it into your browser. I suggest that you get familiar with it, start using it, and what I'll do is I'm going to pop over to the channel I use for my courses that I put YouTube's up there for, okay? So if you go to my, what do they call this, channel, if you go to my channel, wait a minute, where are all the controls? They must have changed something here. Over here. They changed this. Where is the video button? What is that? Why is that? It's an ad. Okay, they changed the interface all of a sudden. This is new. We're going to go to, I got to be able to search on my own videos somehow. Yeah, for some reason that came up as a weird thing. This is the interface I was looking for. So under my videos, what I can do is look for MS Word. And this is a video. I've actually created a couple in the series here. Okay, and this is to help all students at all levels that I have. So this video is all of a sudden it starts running, right? It might not be too obvious, but up here in the left-hand corner, when you load Video Speed Controller, there's a little control box up here if I roll over it. And when I roll over it, I can speed the video up. I think that's the plus. It's hard to read on my own screen even. And I just sped it up to 2x. Now you could do this in YouTube. If you go down to the lower right in YouTube, there's some controls and you can speed it up. This gives you a much higher. You can speed it up to 3 or 4 or 5. So if you watched one of my videos and you knew you saw something earlier, you have to go back to. You can go back and then speed through it till you find it. Okay, so this is a huge thing I use professionally all the time. I just thought I'd add between Snagit and YouTube Video Speed Controller. I figured I'd lend you that. That's a big boon. All right. So when I give you these videos, you don't have to sit there. They're very long. Some of them are long. I think they're going to take 10 minutes and they take half an hour, 45 minutes. Right. So that's why I brought up this Video Speed Controller, so you can speed through them much quicker that way. Okay. So I really recommend that. All right. And by the way, I will make these MS Word, which basically followed the class that we had last week. I will make that available. I also have other videos that are going to come up on statistical process control, which I went into quite a bit of depth of the origins of statistics, of at least normal distribution last week. And I have some videos on that you may end up having to refer to, because we're going to really focus on statistical process control. When you start looking at the world as probabilistic or stochastic, it'll explain a lot of things that are heretofore unexplained. When you have mysteries at work and nobody knows why things are failing, generally start suspecting that just model it as normal distribution. The time that it takes for something to happen takes, plus or minus, it depends. It's normally distributed. It's likely it's going to be at the average, and it's going to be unlikely the further away you get from the average. And that's what the bell curve is explaining. The height of the curve says at that point, what's the likelihood of that as an outcome? Okay, so I'm trying to get you have an organic feel of what that is. All right, because we're going to go over that. And there's a couple of public videos here that I use as a backup for explaining statistical process control. Okay, so there we go. All right, and then the Nicholas is out there. I'm trying to pay attention to your scrolling comments here in case you have anything I need to address. Okay. All right. So that's that. Let's return to the Excel. Okay. So if we come back over to the Excel for just a few minutes, I want to go over the right hand. Now, what I did was I painted a visual separator in my Excel sheet here. You don't normally do this in industry, but this project is just tame enough to keep on one sheet. It's a little less complex to try to do it on 2 sheets. And we last week we went over, I want to remind you, what we did is we started modeling up what it was for those same 12 contracts that we're going to use nominal numbers here, like the raw material time that it takes to get the raw material for a contract. We're using nominal numbers because remember, you're going to bid on something, okay? The idea here is you're using this a priori to actually bidding. You're trying to figure out of all the contracts available to you there, I can give you examples. I mean, the real living ones in there. I can give you ones that have offsetting numbers in there. They're large dollar figure. They're large dollar figure contracts. And without the analysis, we're in MBA world now. Now you're going to attack things, analyze them, and get a tool, no matter what you're doing. I mean, we could teach you just so much here, but the experience is to be like a tiger and going after problems and finding the solution. Usually, it's something you're not quite familiar with. There's usually a list of the dimensions of the problem. At least it's going to be like your checklists for the end of turn at Kibbe Strand, or the end of week, I should really call it, end of week at Kibbe Strand. What are the things you're going to tell people so they don't go through the same errors that you might have, where you go, boy, I really wish I didn't forget to do that, because I might not make it all the way through and pass Mod 4 this time, right? There's a big expense with making errors there, okay? Okay, so let's see where we ended up with the analysis here. I have to expand my column so I can read what we have there, contract days and contract weeks. Okay, so we actually got further than I remember, okay, which is great. I didn't want to spend all night on this. You should, with where we got on this, be able to flesh out this as well. You should get practice. By the end of 12, it goes fast. The first one, you're figuring, it's a learning curve, right? So there's a learning curve involved. And the first one was a lot of work, and the second one's faster, third, fourth, fifth, and all of a sudden then you know where to grab all the information. It becomes a pattern. It's muscle memory, like where to grab with your mouse and copy and everything else. Okay, there we go. So one of the interesting things we talked about was the T-shirt contract. If you start looking at actual times that it takes to run the contract versus the estimates that you make, they're significantly different. In fact, when we calculate them here, we're using our nominal numbers, and they're probably numbers that you actually used and were successful with. This is the point here, is that when we calculate it using nominal numbers, it came out to 8.125 weeks, and I think we're only allowed 8 weeks on this one, right? So, yeah, I can run that really fast here. Let me just double check on that. I want to be precise. All right, so if I go to Mod 4, all I need to do is look at the first screen. I just want to check, but I think that first one was 8 weeks. Yeah, so if I don't even have to play any of this. I don't have to go through any steps. I'm just looking down at the lower bottom here. And so these are the 5 contracts that I euphemistically called you got stuffed with, all right? The old management walked off the job. They didn't even tell you what you had to figure out, if there was even material on the receiving area, or it was ordered or whatever else. You had to build a confidence set around what those 5 are. Did everybody end up having to buy material for those 5 contracts? Take a look at it, okay? Take a look. When you go back in, and this was asked of me by one of the people here, one of the Nicks that isn't here tonight, and so I want to address 2 things first. One of them is what I'm doing here with Nick and Nick tonight. I'm going to do next week. We're going to be remote. Everybody aware of that? So you have to be somewhere at 6:30 where you have a computer. It helps to have the mic. Certainly, you can type in here. We'll probably use GoToMeeting, but between now and then, I'm going to see how live streaming YouTube might work. I might be able to use my channel and stream it. It might do a better job of recording. I don't know. Okay. And what was the other thing? Oh, for your report. And I've said it, but I know how this works is that it's really in context when it starts making a connection with you, and that you'll do it, that there is this one module called the sandbox. The very reason that it's in there is that it has the expiration date is months away from now. It goes through the entire session. That's where you need to go back in and collect all your information here. And as Ludwig was pointing out, there is no dashboard in here. That's worth mentioning. We don't hit that specifically, I don't think, in any of the chapter work that we do or whatever. Some of you may work with dashboards or organized portals. You know, the school has a portal, Connect has a portal. You know, we consider those portals, and they try to be good user experiences, and that's up for discussion. Okay. All right. So those are the two things. I want to make sure I remind everybody that next week we're going to be doing it like this. I'll be out of town. All right. What else? Yeah, and of course, I just want to double up on that and say that the Mod 4 sandbox is where you want to be for collecting a lot of that screen grabbing and information. You might be tempted to put maybe some of that into an Excel of its own, little Excel sheet, but don't. I want to make sure you spend time at the right place in the final report to get the value from it. Okay, so when I get these, as I mentioned, I have instructions. I'm giving you expressing the instructions here. We went over the format last week, pretty detailed, Microsoft Word. The video goes into it. There's a little bit more generic in the video than I speak about here in class and showed last week, because I offered some things there about the structure. For instance, as you're listening right now, you want to take a note. There's one particular area that I'm not sure. I think it's in the description instruction set, but the conclusion standard, if you pick up on the pattern about how to do this report, then you can use it for gaining traction wherever you work, or gaining traction in a place you'd like to work and you're applying to, or whatever else. That's the point of this report, is how to collect, cash in on your success. All right. So when I get this, I'm reading it like one of those executive management people, right? I want to see if you caught the big concepts in there. What did you have to do? What was out of control? And you can be expressive about this. This is, try to use it for the benefit I'm directing you at with this, or directing you to on this, is that raise your standard for however you're writing reports or communicating at work. Adopt it as your people you work with and for know you're going through an MBA. They should see a difference, right? This is what you've been paying for, okay? And it should pay for itself. The class should pay for itself through just that, right? I express that to my undergrad traditional students. They don't get that yet. They don't have the context, okay? How about questions? Anybody with questions right now on anything? Give a second or two here for Nicholas and Nicholas. Okay. All right. Very good. Okay. Doesn't look like anything's popping up too fast. We might have had, I think Nick C went through a tunnel or something. He said he was going to lose service. All right. Okay. So, all right. Nick M, are you able to see the screen? On my screen, I have the screen. Actually, it's... All right, as long as I stick to that screen, I think we're recording fine. Okay. So what I'm going to do is cap that off. If any questions pop to you while we're here tonight, make sure you cover them, because we're going to go a little bit hands-off for the rest of the duration here. We really have, about less than 2 weeks to finish everything up. Okay. All right. So I'm going to grab my pen and clear out the board. In fact, what I have, these are some notes. There's an undergrad that's doing this in parallel with you all, so I'm on the line during the week with him at night. And that's one of the reasons why I tried to record the go-to-meeting, so I could just give it to him, and he could either have logged in or he could just look at it, but it doesn't have any image on it. And these are just some of the notes that I went over with him. It's very similar to the same thing, Microsoft Word video, the premise, and I went over this more with you than I even did with him, but the organization of a cover page, table of contents, try to use the automatic table of contents generator type thing. I think that's in my video. Once you get the hang of it, it's something that's more of a recent thing in the last year for me, that I just I use the, if you remember what we did on the home tab, you have the styles, you have the heading styles up there, and we adapted them for how we want it to look. And then your paper becomes structured, right? So to test it, you can even go into like view. I think you go into view and you can look at it in the outline form, and it will condense it all right down, right? And if you have a really big document, it's a workflow, because you can just click on the sections you want to open it up at one at a time. You can move around inside a document a lot better if you have it with the formal heading levels, okay? So we went all the way through that. The table of contents uses that. It captures that, puts it in there, okay? I went over, just to show you what's going on, I went over the cost of this endeavor that you've been sent on, and the premise there is to write a report. It's kind of a dual thinking. Yeah, this report I have to write to an executive management team, but I want to embed that. I want to adopt it. I want to adapt to this writing style and this presentation. I'm going to guess that business writing is going to be 99% of the work that you do at work. I don't think you're going to be doing too many MLA formatted documents at work. I don't know. But that goes for future research. You really want to know that, the other research type writing. One major thing I'm going to comment again about is in business writing, it's inverted. Usually you make your power statements with substantiation. It often tends in research, you set the table, you set up a framework, you explain all the things you set up, and bang, this is what the result is way, way, way at the end. I mean, if you get in the habit of reading papers, you read the abstract, the first few lines, and the conclusion first, and then you find out if that's that interesting at all to you. Is it relevant to what you're looking for? Here, your executive summary is everything. Your executive team will only read that. They'll be relieved. They're so busy, they'll put it on their desk and wait for you to get in and have your big meeting or have your go-to meeting, whatever it is. You might have a on-site meeting. Okay. As another comment for professional work, if you're a Wintel person, if you use a PC rather than an Apple type product, I don't know if they have something like this. They probably have something better in Apple for this. But this is OneNote. And I, by accident, just started using it a lot, and I have a drawing pad. So while I was drawing on this, I have an actual electronic pad, and I was writing all that. And that's become a workflow for me. And because this is operations, I mention these kinds of things, like things that you might want to adopt. And they're automatically saved. You never save it, and I think it's in the cloud. And you just keep adding pages to this. I have many, many notebooks on topics, So like for yourself, you could have a writing pad with your computer here or for any class that you take, and you could be just writing your notes in here, and it's all captured right in there if you had a little pad. I think I paid $69 for a Wacom tablet, and I've had it for like 6-7 years, and it works fine. It's like has never gotten obsolete. Just mentioning it. Does anybody here use a tablet at work where you just write on it like that? That was going to be the thing. Like everybody was going to have this. I mean, we're talking about 12 years ago, and it just never kicked. That's the way it was going to be, like the work style. All right. Okay. So now I'm returning to the second half of last week. Okay. All right. Oh, right there with the Excel. I was thinking of the book chapters. I was like, oh, yeah. Okay, let's do a quick dive. Let's go back over there and make sure everybody understands. All right, so to keep moving things around on my screen here. I don't think I need to look at that. Okay, so the parallel to the left-hand side, the profitability side, there's three things over there. Like there's three big costs that we were monitoring over there. We really watched only three things in scheduling. So that's one thing to keep in mind. So one of them is, if it helps, what I'll do is I will paint that like I did in the other one. So you'll have three areas that we're after. We want to know, so this is time. The other one was money. This is time. And what we just uniformly said was when we're bidding, we're just going to go with a nominal 2 weeks it takes to get the order the material and get the material, right? Then we have the shop floor production time, and we had to keep converting it from seconds all the way out to weeks. So let's paint that one as yellow. Whoops. That should be right. I have to flip the... There we go. Okay, so that's the second thing. Okay, and then what was the third thing? I knew we didn't get to something. I'm glad you asked, because I knew we didn't get to something, and now you just made me realize we didn't get to shipping. Didn't I throw shipping in here? thought I did a screen grab, or we ran out of time. Must have been we ran out of time. Let me just take a quick look around here. All right. Okay, let's finish it off. Okay.
You're saying on with that middle bar, middle purple thing.
Right.
On the left side, that's the
Profitability. Yep.
profitability
Yep.
analysis, and then on the right side, this would be schedule.
Right.
Okay.
Oh, Control Z. Right. Okay. So what we might do is treat ourselves very nicely here. We're going to insert a row. Okay. So I just inserted the top row here. Okay. And up here I'll put schedule. Okay. So you have liberty to arrange this. You don't have to. It doesn't have to look exactly like this. You can be kind to yourself any way that you can remember it really well. Because way back over here, I don't think I ever put in here profitability. I wrote it on the board, I believe. It's profitability, right? So I'll try to match things up. I'll paint that orange, for the lack of a better color. And the other major section will be orange, schedule. You can dial that up a lot of different ways, but I'm just going to make. Does that help so far? Get our heads back in here, yeah. Okay. So we figured out what the production floor. That's just. It actually helped bring up. We didn't finish this off. What we figured was 8.125. What is it? 125 an eighth of a week. Okay, like a bunch of hours. 8 weeks and a bunch of hours, just for production floor time. And we're only given 8 weeks to get that done. If you go back through your records, you would see that you actually got this done a lot faster. And this is a big point I'm trying to make, and that's going to be a quiz. Why does this come out shorter in real life than in our estimates here? Okay, because we have pretty good estimates of what's going on. The production floor is going to be what it's going to be, pretty much. There might be some slippage around ordering materials. You might have some on hand, or you might have it faster, you might have it later, whatever. Okay. So the last thing is shipping. I didn't do this? I must have run out of time. Okay, so shipping, we might as well go over, and I'm going to bail out of this one. I need somewhere where I can actually work. Otherwise, I have to go through the entire 40-something two-step tutorial to be even able to do anything in there. Okay, so I'm going to load mod 5. Okay, mod 5 doesn't have a tutorial on it. Okay, so I'm just going to go to the shipping floor, and I'm going to take the table, and I am going to use my fancy Snagit and copy this right out. Okay, because I'm going to end up using this. I don't want to make any mistakes. So I'm going to just drop it in as an image. I just dropped it into Excel. You can do that, All right. So you can move it in, get it out of the way if you need to. You can move it around, right? Okay. Okay. I did this with the undergraduate student. That's why it seems like I did this. Okay. All right. Okay. So how do we? No, you know what? I got confused. Get rid of that. I think we already have it in there. That's the money side of things. I'm sorry. Oh, I went past it. Yeah, I had done this. Okay. There we go. There it is. What should we allocate for shipping? Time. I forgot. We're doing time here. I beg your dear pardons for going off target there for a sec. Okay, so this is the third thing. The third chunk of time that's involved with the contract is shipping time. What should we put in there as a nominal number? We use 2 weeks as an average for ordering material. What should we use for average shipping time nominally? Do you remember what it used to take? How long does it take to ship? Actually, you can go to the table. What were our options? What were the options? How long it would take to ship? Right, there was regular, expedited, and like some kind of weird thing that just showed up over there. No time. It was like no time. It just gets there. Yeah. So if you look at the table here, we had standard was 2 weeks, expedited was 1, and then priority was 0 weeks. However, that happens, right? Right. Okay. So if we're just the idea here is to get a rough estimate of compared to what we're given as far as time as to what it's really going to take. How many weeks would we use? So what I'm suggesting is when we do this kind of analysis, you would use the same number for all the contracts. You're just going to, whenever you see the contracts up there, you're going to say, what's coming out as the real variable here? Not so much the ordering. What would make an order take a material order take longer than 2 weeks? What causes
Lead time and number of deliveries.
volume? Yeah, I mean, if you just have this really big order, that comes all back to those factors you just mentioned. Those are nice specific factors. In general, if you have a really large order, you have to split it up.
What would happen is you would need a specific quality for an order, and the manufacturer that made that quality level would have a maximum order of 250 or 500.
Right. It depends on what reputation they had, right?
Exactly.
Right. The lesser reputations were smaller. You could buy little lots from them. They would go up to 250 sometimes. I think some of the small orders, and then you'd have to order from the big guys that would they would have all kinds of other incentives to split it up and everything else. All right. Okay, just to make sure we know what's going on in our factory there. Right. That's what that's about. So, what would we use to just estimate shipping? Is there a volume effect on shipping? Compared to buying raw materials, what's the impact of volume on shipping time versus the volume of buying material? We just described material. If you have a really big order, you might end up having to take it over a bunch of weeks.
The biggest issue is I found to be the number of employees you had in your shipping department. So you would be limited on the volume you could send out based on your manpower.
Yeah.
Your manpower
Yeah.
exceed.
Yeah. You could chunk it out, though. I mean, would you? I'm going to have you repeat what you said before we started class. What happens when you hang on to finished product?
Storing other people's stuff.
You're basically right. Yeah. That's why places, want you leave your car, you can't leave it for more than a couple of days. What is it? There was a kind of a joke there, right? You leave your car in a shop when you go down to the New York airports, just leave it there for 2 weeks. You don't pay, but they know about that, so they don't want you to do it. Okay. You're gaming the system there. So we could, it's not as variable in the shipping end of it. As long as you have people there, you can chunk the whole thing out if it's 900 pounds or, 1,500 pounds or whatever, right? If you release it, it goes, okay? But it's a little bit more tenuous on the incoming side that the actual supplier, at the other end of shipping, the customer will take everything, but the supplier can't sometimes supply more than a certain amount every week, right? Right. So it's less variable is my point here. What would we throw in there for shipping? What would you throw in there, as an estimate? What would you do as a rough number? Just your rule of thumb. It's a policy. You talk about this as a policy. The core policy would be the way we estimate is 2 weeks on material and what on shipping. That's all we're saying. I throw it in there too. Right. Yeah. Because faster than 2 weeks ends up in more expense, and you know that, and you'll factor that in later on. Sometimes you don't know until it has to be shipped whether you're going to need to expedite it or not. So we'll throw 2 weeks in here, okay? And this actually is proving a certain point, okay? So it was bad enough that just the floor production time was greater than the time we have to actually make this thing, okay? And so as a business owner, you've taken full ownership of this problem, as a business problem owner, right? You have to know what's going on in there. What happened here? How are you able to actually get this out? Because the total is going to be equal to the shipping, the total time that is going to be equal to the shipping and the floor production time and the material acquisition time. I think I put that in there. Let me see if I did. Good. I think I actually did that correctly. Woohoo, So if we're just using numbers you've used a lot there, it's not like we made a mistake. I think we're solid that it's not bad to estimate material and shipping to each be 2 weeks. That's 4 weeks. That's half of the time. That's half the time it takes. So you have to consider that when you're bidding. That's a problem. Like, that you got that T-shirt contract through well. Somehow you beat the system, right? And again, I'm going to use that as one of the part of all of one of the quizzes. We'll have 4 quizzes. So I'm having you think about that. I'm going to give you a heads up about that. What is it? What is different about that? It has to do with the manual that you were given, okay, when you showed up. All right. All right. So did that help you? Does that answer your questions? You're good with that? Yeah. It took me a second to remember what happened when we were here last week. So. I might have to save it over here, okay? Because I'm working over here again, and I didn't show the guys at home. I got to practice that. All right. So we're done, but that's good. That's what we wanted to go through here tonight. Where are we here? Good timing, okay? So I'm just going to close that out. I don't need that anymore. Save. All right. I guess I did save it over here. All right. Let's hit. Okay. I don't think I need that. If anybody needs more, has a question about practice, I'll go back in there later. Just going to clean up my desktop here a little bit. I don't need that. Again, it's a video speed controller. You might want to add that into your browser. Okay, so, all right. Now I'm going to go back to where's my OneNote? There's OneNote again. Okay, so let me come back to OneNote, all right? And I want us to think through. I'm going to give you the framework about what statistical process control is, right? So we've spent some good time figuring out the nature of math, the nature of numbers rather, not math. The nature of math, and it should make us feel happy that there's not in real life, there's not a true average. It's a construct of human imagination, and math is imaginative. Math is like modeling and framework, a framework that helps us predict, okay, model and predict, okay. So I'm going to go over that quickly enough in that keep straight that we have raw data, temperature data for 100 years, or weight data from motorcycle helmets. Maybe we're sampling, we're picking some number randomly, we don't have every 10th helmet, we're picking it out randomly. 2 in a row, we weighed 18 more, then we weighed 36 more. We're really randomly picking these out, but we have 100 motorcycle helmets that we weighed. Okay. Okay, so we have a list of data, and we have an index or identifier for it, an index, right? It's just numbered, the sequence of recordings we made. This might be every 365 days if we measure the temperature on the 5th of August for the last 100 years, or it's just an index that we're really, really randomly picking off helmets off the production line, okay? And we're checking the weight. And we use root cause analysis. When we start taking a look at quality, right? One of the standard methodologies is using root cause analysis. What exactly is causing a problem? Well, we can back into this. If the weight is off a little bit, sometimes it's quantized, and you can tell, well, that happened over here in this process. If it's off by this much, it's a little like double entry bookkeeping, as a matter of fact, right? It's like chasing down errors in a double entry bookkeeping is sometimes the numbers quantized, and then you start looking for some error in there. I'm not sure how much closing the books you did and such in your classes or in real life, but that's what it's like. You have to hunt down the pattern, like where the most likely spot where something might happen. It's quantized, right? Okay, so I've probably over-explained this already, okay? What I'm saying is, just keep in mind, is a simple thing here about numbers. We have a bunch of numbers like this, and since second or third grade, plus or minus, we can figure out the average, okay? This is just a refresher as to where we were, okay? And then temperature data and a lot of other data, the way that it behaves is when we say normal distribution, okay, there's a very important part of this. It's the central tendency theorem, okay? Central tendency goes hand in glove with what normal distribution means. Central tendency means the data, it's a horrible drawing. The data looks something like this. What does this say? We took the list of numbers, we counted up the frequency of anything in there, and then for every value, every unique value, and then some, in this list, we counted how many times did that happen, okay? So if you only have 100 years of temperature data, you may only have maybe 5 or 6 or 7 points around the average, okay? Because you have to remember, all your points, the number of them add up to 100. So maybe the height of this is 6, right? 7, 5, because now you've already accounted for 18 of your 100. And for every other temperature that occurred, you calculate how many times did it occur. And if you have a lot of data, then it smooths out like this, and you start seeing the shape. And what we're saying is a lot of processes naturally are normally distributed like this. To be clear about that, we talked about a die. You roll a die, what's the odds of a 3 coming up? The same odds as a 2 and a 1 and a 5 and a 6 and a 4, okay? So just to make sure we understand, we should talk about another probability distribution function like this that says, went too far. All right, okay? So 1, 2, 3, 4, 5, 6. Each value on a die has equal probability. There's a little p, right? The probability is equal for all of them. That's uniform distribution. That happens too on a die, okay? So if you want to get really good at, craps or something like that, you can figure out what's been rolled and what's the likelihood of other things happening, and that's where it's gotten really technical with poker, right? If you go to poker side of things, people count cards, they can figure things out. Anybody that has a good brain, beyond my ability to memorize, I couldn't do that. But anyway, some people are that good that they can memorize. And there was a bunch, I think it was like Harvard students that ended up getting chucked out. I mean, this is like 20 years or 30 years ago. There's a book about it, and there may be a movie about it, is the Harvard students learned how to count cards. They deliberately worked together to do this, and they started making money. And then they got recognized. The pattern started setting up with all the cameras in the casinos, and they figured out that they were blackjack. It was blackjack, and they were counting cards, because in blackjack you have like numbers of decks of cards. I don't know how many, right? So they had to have a really good memory. They were very, very, very bright people, right? Okay. So what happens? How does this relate to what goes on in the factory? Okay. If we look at this data as though it were the weight of the motorcycle helmets, what did we figure out? You looked it up, like 4 pounds was a motorcycle helmet there, Ludwig, something like that? Something like that. We'll use that, 3.6 or whatever. And so when you make these motorcycle helmets, the customer sets up something. The gist of this is that you have some kind of customer specification. So the lower spec limit and the upper spec limit is this. It is what it is. They have their own knowledge that they say we can't accept it anywhere. Now, in real life, the manufacturer often drives helping the customer set these numbers. Okay. Now they've set these numbers. They might say it's 3.6 pounds, and it can't be any less than 3.4 pounds and any more than 3.8. For all our discussions here, we're going to talk about like symmetry around the center point. Technically speaking, there could be reasons why they might accept a different. See, we're minus 0.2 pounds. They'll accept minus 0.2 pounds to plus 2.2 pounds, right? We subtract 0.2, we get 3.4. We add 0.2, we get 3.8. Okay? All right. Now what happens is we have a process. Does our process feed as a good supplier the motorcycle retailer, the motorcycle brand name? Okay, they've contracted us to make these. Well, what does this say? What if our process really looks like this? After we I'm trying to figure something out here. I have to turn the board off. People at home can't see this. That's why I keep stalling here. I'm trying to figure out how to get this working the right way. What I need to do is show them the camera and turn this off. They're not able to see the picture. It's pretty dark all of a sudden, right? This is for Nick and Nick. How do we maximize that? I think it's part of what happened last week. Okay, so now Nick and Nick should be able to see that. All right. So. It is off by an hour. It took me by surprise. All right, let's get back into this. So what happens is the customer sets these goalposts, all right? And let's just take a day where things are going well. Why does this shape say we're doing well, and the next day we're starting to have results like this? What are we defining there? Or how do we describe, why is this a good day? Why is this a bad day? This is the distribution of the weights of the motorcycle. This is the actual, all right? After a day, after maybe this is today, and then tomorrow something happens, all right? What could happen in a factory? I don't know the technical details, but when IBM was producing chips now, it was maybe it was like 30 years ago over there, they stumbled upon some quantum physics property of semiconductors that ended up kiboshing the performance of their chips. They couldn't understand what was going on. There was some alpha something was going on in there, and what goes on over there, or in semiconductors, is based on quantum physics. It has to do with energy levels jumping and some advanced wackiness that goes on with doping semiconductor materials and such. All right. Okay. So they have all of a sudden their yield went down. And they had a contamination at the quantum physics level. Like who's going to figure that out? You need like Einstein, and where are you, right? So why do we say a wide distribution? It's saying we have a lot of points further away from a target. Why do we say that's a bad day and that's a good day? Yep,
so your
that's right.
tolerances have extended out away from what you're
Yep.
wanting.
Yep. And that's good and technical. That's kind of a good technical kind of verbiage around what's going on here. In business terms, out on the floor, we all understand this, but then we have to go back to that executive management. We have to tell them something. Now, they don't want to know like the technical level of this. We can show them this picture, and what can we talk about this? Why did we have a bad day today? It's all spread out, or whatever. In like lay terms, in understanding, can we explain just in simple terms what good and bad was going on in our factory? It's along those lines. It's just like bring it down to explaining it to your mother. It's virtually what Ludwig said, but can you express that? I really want you to be able to express what's going on in a factory, Because if you can understand this, if not, it's going to be like an image that goes by, you're going to leave the course and it's not going to have the value. These pictures are used to explain commonly what happens in factories and in service organizations and everything else, right? You're going along the entire year, you're going to win an award because why? This is good, this is bad. We had a bad day, and now we're risking getting our award. Why is that? It has to do with the goalposts. If we make a lot of things between the goalposts, how do we say that? Here, we're making a lot of things outside the goalposts. Okay. Yeah. Bad stuff. Nobody wants. Ends up in the scrap heap. Okay. So I want you to understand these pictures they don't come first. The situation comes first. We had a lot of stuff that didn't meet the customer what they wanted. Those are the lay terms. That's what I think it was Bill Gates or someone said it, if you really understand it, you can explain it to your mother. Okay. I was working with high school students from here, and we were doing a program, and I had these little rubber ducks. And in programming, and it's beginning to go into other areas. In programming, if you go into programming rooms where people are programming software, you'll see a lot of these little ducks around. And it's the same idea. If you have a problem, or if you want to own a topic, you've got to be able to explain it to the duck, right? So I gave out all these ducks, and then my other students found out about it, so I gave them ducks, my undergrad students. And the fact is that is a really good way to know whether you understand something or not. In fact, that's my own metric, is if you can put it back out there, make a video about it and talk about it and everything else, then you own it. All right? So this is the level of, you're going to look like geniuses if you understand what these curves mean. Okay? It just means that we're counting how often something happens, and on a good day, for this value, we had this many times it happened, and for this value, this many times it happened, and that's why it gives us that curve. It's a natural order of the universe issue. The world works like that, the central tendency theorem. You could have something, I don't want to confuse, I don't want to distract, confuse, and get off the grid here, all right? So here, if you look at the area, so we have to start conditioning ourselves to looking at the area under the curve between the lines. And here, most of the curve is between the lines. And here we have a whole big area. This area is relative to each other is equal to 1, okay? The area underneath this curve is the same as this curve. And what ends up happening is we have a lot of area outside the marks. That's scrap. What's between the marks is what? What's a good word for the stuff that we get that comes out of the middle? The yield. We call that's the yield. Okay, that's the tech operation terms for the yield comes from what you can turn over to the customer or a downstream activity, and scrap, as what we used, is depending on what you're making, sometimes that can get recycled, sometimes it can't. All right? Okay. And there you have it. Okay, so that's first half of understanding what's going on. Now, you could talk out loud. I'm in the room. I'm here. Okay, she can come in and come to and bring her back. That's right. That's the kind of people we are. All right. Gotta love them out. All right. Okay, I'm trying to remember or figure out which way I want to go with this. Okay, so we know how to calculate. We have these two equations that tend to look similar. So the standard deviation, little siggy. All right. What was the standard deviation? Try to go back to how I explained it last week. What was it all about? We had the simple average, and then all we're really looking for, another word for the standard deviation was the average distance to the mean of all the points. It's a very logical thing to think about and to understand data. This kind of data, we said, what's the average distance, right? So we have a whole bunch of points that it's a weighted average. A whole bunch of points that are close to the average, so their distance is going to be very small. And then we have very few that are very far away, so their distance is going to be pretty far. So we're going to take the average, a few points out here and a lot of points here, and all the ones in between, the continuum. Okay? So if you remember that, then you'll remember the equation, and I recommend it, or that's how I'm trying to teach it, is a very organic feel for this to understand where it's coming from. So embedded in here is the fact that we're going to take every point, and from it we're going to subtract the mean, right? However many points that we have there. And so for every distance, we're going to add this up. We're going to make a counter here for I is equal to 1 all the way through n. We're going to keep looking at all those distances. So if we had 100 points, we're going to have 100 distances there. Take every point, we're just going to see how far away it was. And that's really the gist of the standard deviation. The only tricky trick about it was the manipulation that we had to do like that, right? But if you remember the core, and you remember, why did we have to square it? Let me remember from last week. What happens if we didn't square it? We left that off. And we left this, you would end up with 0. What ends up happening, the sum of all those things, if you have perfect data, it's every point up here would cancel out every point down here. That distance would cancel out that distance. So we had to do something. So first we said, hit it with absolute value, and the smarter math people of the world figured out that's not the way to go. That was a dead end in math. That if you go like this, we can keep continuing. We can actually develop the calculus of this probability and statistics business, okay? So I'm trying to go over that a few times so you can kind of see it a few times and embed it, the rationale about how to even remember what that is. It's better to remember why you're doing it than that ugly thing. Back in my engineering undergrad days, I hated this stuff because nobody was explaining it to me. I was like, what is that? What does that mean? I had to memorize, and I was lucky on a test, and 3 weeks later, I wouldn't remember what it was. Yeah. There was rationale and whatever, motivation behind this, okay? Yeah, right. Okay, so we get this number, and it's the average distance to the mean. That's the motivation, okay? It's a contorted average distance to the mean. We had to do this nasty thing to it, the little 2e and the little square root-y, okay? To make it work to get to linear regression, okay? You don't know, but if you understand this, the next few steps, you go, oh, now I see what's going on with linear regression. Now you have these lines, and you're measuring how far your points are from this. I get it. So it really isn't interesting as it starts rolling along. If you get this, it'll take you into the next levels like that linear regression or whatever. All right? Okay. So once we get this, these numbers are in pounds. Okay? Now, it might be ounces or something, like weight, okay? We're talking motorcycle helmets. What is our standard deviation going to be in? Bring it on home. Bring the thinking back home. It's also going to be in pounds. It's like, what's the average distance to the mean? It's going to be how many pounds away from this on average are the helmets? I go over this, say it over and over again to keep driving this point home. That's a very natural thing to be thinking about with maybe a, kind of an off-putting calculation. Okay. So once we know that number, we can draw the standard deviation on here. That's all we do. We're going to end up chopping this thing up. You've seen it before. We start chopping this thing up. Very common in statistical process control. The starting point, sometimes the ending point, is we're going to use plus and minus 3 standard deviations. We're going to start looking at this very arbitrary. It works for us. It works a lot. It's a common start. Different factories can use this term. They all understand it. And what's going to happen is we're going to find out that one standard deviation falls on a good curve like this, if it's a fairly ideal curve, or if it's actually your first standard deviation is that far away, and it's going to come to that point where it intercepts is going to be right here. If I give you a correctly computer-drawn normal distribution curve, and I go, just draw them where the first, second, and third standard deviations are out from the mean, right? If I didn't give you any of this, you just draw a line down the middle, and you'd go, I know by generalities, this is where the first standard deviation occurs. The second one occurs somewhere out here on this very sharp part of the curve. And the third one will end up out here. All I can explain is usually you have a little bit of height left. You can still see a little bit of height. That is so bad. Don't let Dudley know I've been talking about it this way, but this is this is like the practical shop floor value of what you're going to look at, and you're going to say 1Z, 2Z, 3Zs. You could draw that. I could give you that as a quiz question. Excuse me. A quiz question. All right. Okay. There you go, right? So then there's this thing, hopefully we can maybe remember from other classes, and this is going to take us into this other part called the Z value, right? Okay? It's not as scary as it looks, right? What we can do is, if we work backwards, we say, and Ludwig has this memorized, which is good, because this is what you really kind of operations want to memorize is, what part of this area, if we consider all of the area 1, okay, it's a very standard curve. This is a precision curve here, where, as I said, I could give you this curve, a sheet of paper with a pencil, and you can go bang, 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 bang. Approximately, that's where 1, 2, and 3 standard deviations from the center occurs. So you could draw the line down the middle as the average, all right? Okay? And what we know through practice is between plus and minus 1, so this is minus, there's the average. So if the area between the curve between plus and minus 1 sigma, see, we're just working over the sigma. We're overusing the sigma now. We've got this measuring tool now. It's this big. It's the average distance to the mean. And we go kerploppy, kerplop, kerplop, 1s to 2s to 3s, right? And the area between, so we just start chopping it up and go, what's the area between the first two, plus and minus 1 standard deviation, and good memory Ludwig there says about 68% of the curve falls in there. Okay? So what that means is, if this is our process, this is what we're capable of, okay? So what we're capable of is the drawn here, okay? The customer just tells us usually symmetric upper and lower limit of what's acceptable, right? So if they said, if on our actual data here, okay, if our variability of output of the helmets, if the first standard deviation was minus 0.2 pounds, plus standard deviation is 0.2 pounds, as we had before. I'm redrawing the goalposts that they had set for us. If our process, if we only fit in their goalposts minus 1 to 1, our yield would be 68%, and everything on the outside is rejected, recycled, whatever else. We have to deal with it. Okay? So there's two ways. I'm a startup company kind of guy. This is something you would design for a startup company. You would talk to a customer and say, look, we're not magic super people, Our processes are going to probably be like this at first. So the price to you is going to be kind of high to cover. We're very earnest about making our process very good, but we have to cover losses here. We're doing everything we can to stay efficient, recycle, and recover the costs of scrap. This is year 1, right? Then you get to year 2, very carefully, without killing myself over here. Right? So I'm going to get rid of our uniform distribution. I have so much stuff on the desk, I don't know where the eraser went. Hold on. Okay, let me get rid of our uniform. We don't need that. Okay, so second year, this is the first year. The second year, see, I'm going to change the scale a bit on this. They have not changed their spec, okay? So here's our average of 3.6. We notice something though, we're centered. We're okay with the center. The average is okay, but we're throwing off scrap off the edges. We're building too many things that are either too light or too heavy, right? No, you notice that we're okay, we're centered. It's not like our average started way down here too low or too high, okay? All right? So that's going to come up later. Generally, your processes will vary. Later on, we're going to take a look at this. We're going to look at the other dimension when the thing drifts around. That's where Six Sigma comes in, okay? All right, because a couple things can happen. We can either have a really widespread results from our production, or we could have narrow. But the other thing to vary is that the whole thing slides up and down, it shifts. So if you're making ice cream cones and the temperature outside changes, if your equipment doesn't have what we maybe call like colloquially like headroom in it to cover a 10-degree change, it might start chugging real hard and not be able to cool down your buildings and ice cream, and that's why your whole process starts shifting down. Everything starts moving together. All right. Okay. So here I'm going to mark. Notice that I'm drawing a little bit differently. It's like a different magnifying glass. This is still down 0.2. This is still up 0.2. I'm going to remove this. It's just going to be too confusing with this in here. Okay, so the range that our customers are allowing is 3.6, and I'm just redrawing the dotted lines. All right, it's like a different magnifying glass. It's all the same distance, right? Okay, and the next year what happens is we're able to squeeze. I'm using some marks here. We like to use these even or at least unit numbers of standard deviations to talk about things. So our curve's going to look like this. Okay, so there's our first standard deviation over here. First is over here. All right, we got to do it like this. Okay, draw it better. Okay, so what I'm trying to get at is now between the goalposts never changed. We squeezed more production toward the average. More of the things came out close to the average. In fact, their goalposts now line up at -2 to +2 standard deviations. Get it? So we're able to. Second year we got better. We're building things. More things are being built near the average. They're not so far out. Before we had 2 sigmas. Actually, we only had plus and minus 1 sigma contained. Now we're containing it better. Okay. So here's their marks. Okay, here's their marks. So here's the 1 mark from last year. This is where we were last year. Now we're only losing beyond -2 and beyond 2, to which Ludwig already gave us the number, which is, what was it?
95.
Roughly 95. Okay, guess what happens the third year? You're never going to guess. Right. Now, here's their 3.6 average. All right, and they haven't changed anything. They still allow us anything from -0.2 to +0.2. They allow us. Remember, those are their goalposts. We're superimposing our process in the middle of this, and then the third year it looks like this. What did we do? We squeezed more of the area of the curve between their requirements. What's a little throwing this off a little bit is I've changed the actual physical span between their upper lower spec limits. So this is called the lower spec limit. This is the upper spec. The spec comes from the customer. Okay. Now, what we talk about are control limits. So generally we say for the first 3 years, if we can hit really what we would call 3 sigma, okay? You kind of call it 3 sigma, plus or minus 3 sigma. We want that quality in there, right? Our control limit, we're just watching where the 3 sigma occurs in our model or in our actuals that are happening, or that are coming off the measurements coming off the shop floor. All right. Okay. So now this is -3 to 3. Okay. So your average is still 3.6. Now we've just much more of our production is between the lines. So what we did is we've gained the area from -2 to -3 down here, and the curve from 2 to 3. Now that's contained. We've actually won. Okay, so we won a little bit back. but you can see it's diminishing returns here, right? So what was the number we have now? Now what is our yield? It went from 95 to, right, 99.7. So we actually, by gaining that last sigma, we squeezed it in. We've gotten more to work. We've dialed it in. We've calibrated things. Everything's really working well. We found root causes. We got rid of drafts on our ice cream or whatever it causes these problems. We gradually, in the learning curve, we knew that it comes with time. We'll get there, all right? So 3, when we talk plus and minus 3, you see a lot of problems like, you get a problem that we'll talk like, okay, you know, our control limits between plus and minus 3. That's like very standard way to begin thinking about your processes. 6 sigma, just to give you a preview of what that means, is roughly, instead of plus and minus 3, you have plus and minus 6 sigma between the customer specs. You've brought more things that were outside acceptable into under the acceptable realm. Okay, so into the acceptable. Okay, all right.
So because obviously you can't just do that. That costs money to do that, right?
Yes.
Because now you're hiring better talent, you're buying more precise machines, you're controlling the environment, your machines are in more in order
training people, learning curves,
You have to put money into to get that curve higher and higher up. At some point in time, you can't just keep jacking up the prices on your distributors. So they don't care about your air conditioning bill.
Yeah.
You know, to keep your machines from expanding and contracting.
Yeah.
In order to get it all the way. So I guess what I'm asking, because that's the real point of diminishing returns to me. Is once we put so much money into perfecting a product, then no one will buy it.
Unless it's, well, that's the source of employment out of this course, is because it occurs in semiconductors. Why is semiconductors this originated from Motorola, Six Sigma? Okay, this is the generic approach, plain vanilla, and then when we get to Six Sigma, we're going to find out that Motorola was one of the first companies that started going for Six Sigma. Why is that? It's because the density of transistors on a circuit was getting finer and finer and finer. They can make smaller, 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 meaning what? More and more and more. And that means that it was meaningful in that setting to talk about Six Sigma. Okay? Okay? Technically, in Six Sigma, what is your yield? So if plus and minus 3 is 99.7, diminishing returns, in the semiconductor industry, it was determined the cost benefit of it was they just had to have a yield at Six Sigma, which is really plus and minus 6. It's really 12, the width of it. They went to 12 because there was so many things to measure. There was such fine transistors. It's quite amazing. I mean, just an amazing feat that they've pulled this off. But what is the yield for -6? I'm going to tell you what it is because we're going to get into calculating this stuff tonight. Okay. Technically, this is 2 parts per billion. Okay, it's so small you can't use percentages anymore. All right. So let's see if I can even write that out. 2 parts per billion loss would be tens, hundreds, thousands, 10,000s, 100,000, millions. What? Is that it? It's rough. That's 2 parts per billion is your loss. So the 9s, just reverse it. Yeah. Yeah. But it's diminishing returns. The more you're grabbing and the higher yield you get, it just the economics of that made sense. Then they had to apply this to other worlds, and the reason that it shows up in other worlds is what else? Where else are you going to measure so many things? You know, a silicon disk that they put transistors on might have billions of transistors on there. You know, so it's within the realm of what you're making. All right, it comes to this. Okay, so I'm spreading out. I'm giving us some of the what do you call it? sugar instead of protein right now. This is kind of like the upper level kind of thought process about Six Sigma and whatever. What was I going there? Oh, so if you have a process here and you have a yield of 0.99, oops, you probably recognize this from other courses or whatever, and then you have a following process that's 0.99, okay? What's the yield out of this? 0.99 squared, which is less than 0.99, and it starts chaining. So anything where you have a lot of chaining going on, which is like everything, where you have chaining and you have errors and you have yields and rejects in there. I just want to check my mic. There. I think I could. Yeah, I think they can still hear me. All right. That's where you end up with something with many chains. You end up in the same boat. Even if you go out to 10 on this, we'll do some calculations, fast calculations that of interest, some practical things that we're going to do. Okay. All right. So how do we get from? Let's keep our equation up here, x of I, sum, minus the mean over n, this part squared. Every time I do it, I go through what I've delivered to you. I mean, I go through the logic of this, so I never forget the equation. It's the logic of what that means. If you take away the square root square, that's the average distance to the mean, if you look at it. Okay? All right. So, okay. So there's a formula that goes along with this that says in a normal distribution, let's talk in terms of rather than native units like pounds, if we go to a generic system, we just talk about numbers of standard deviations away from the mean, then we can have a generic world where somebody doing biology and measuring microbes in a petri dish and somebody measuring temperature, and somebody like us doing motorcycle helmets and weights, we all use a standard approach to this. And what we do is we take the native units, and we want to turn native units into terms of take the native unit, but refer to it in terms of that standard deviation. This is where things starts getting interesting and useful. We're going to use the standard deviation, all right? And the way that this works is we have a standard function we can use in Excel, and there are tables. Okay, so you've probably used tables. I don't know if you've used. It sounds like Dudley had you using formula in Excel for statistics, right? So how do we get from like area to percentage here? Okay. So what we do is we assume that we have ideal data, right? Okay, and then we say, what's the probability that our motorcycle helmet, so we're going to look for this area. The idea here is remember this is a distribution of outcomes, of frequency, or probability, right? Okay, so the frequency here, the frequency directly relates to the probability, right? The height of the curve tells us how many times this thing happened, right? And then we know how many readings we had. So if we look at motorcycle helmets, we looked at something that was, pick a point here. I want to get off of the numbers we're using. Let's say it ended up being, by 3.5. We're down 0.1 of a pound down on the scale somewhere, okay? So it's down here, 3.1. We want to know what's the probability of a 3.1 happening. Okay, so we look at this. We start learning to look at this in terms of area. Okay, what is the area here compared to the overall area of 1? Okay, and underneath Excel and underneath the tables that you've used, there's a formula. You could actually look it up in a book and create a cell inside Excel with that formula, and it will tell you something about that. Do you want to take like a 10-minute break? This would be a good time to do it. We'll just take a little break here. Whatever you feel, okay? Let's see if there's any messages coming in from those playing at home here. It's pretty quiet out there. All right, stay awake, guys. Stay awake. We're almost there. Okay, I see some writing in there. There's Nick M. He's still with us. I don't think I've seen Nick C lately. I don't know how he's doing. He's in a tunnel there. I took the mic off. Nick M. No, he's there too. I see both of you there. For you all, I'm going to switch mics because I have two different kinds of mics, and if you can tell the difference between them, if the first one that for the first half of the class worked well, I'll go back to it. But I just want to try. These are different technologies, so I'm going to switch this out. Trying to get this as set up as I can for next week when I'm going to be out of town. Okay, so I have this other one here. You may not notice any difference. I don't know. Put that on for a while.
high degree of suspicion this is leading into something much akin to the mold in chemistry. The universal universal variable name thing that I hate with a passion.
Yeah.
Pretty similar. Let's start counting just the deviations.
Yeah, right. We want to figure out for any point there what's the probability of anything up to and including that event happening, right? Oh, are we all back? There's only two of us now, right? Two of you will. Okay. Okay. Looks like Nick and Nick are staying awake back there. Okay. Let's try to use the last calories of energy of the day to finish this off. Okay. Because this I'm going over this slowly and carefully again. So hopefully you've heard it before, seen it before, and I'm just trying to make sure we can make as much sense of it as possible. All right. Okay. So the behavior of this that we're using, one of the properties of normal distribution is it's symmetric, right? Okay? As we can see, if we have ideal data, it's symmetric. It became that problem that led to the square root and the square that we talked about last week and again this week. All right? Okay. So how did we get at the 68%? How did we figure out that this is 68%? Well, the way that we did it is our function. Now, there's many formula that you can use on pencil and paper or in Excel. Okay, so Excel has a lot of these built in, right? One of the formula that we use will return to us the area of the curve up to and including a point, which is useful to us because we want to know what is outside of the acceptable area. And we have a left wing down here, and we have a right wing that's going to, they're symmetric. Okay, they're going to be symmetric, which makes it a little bit easier for us to do these things in general. Okay, now a couple of things that can happen in real life that we don't get into here is you could have skew. Okay, so you could have I'm trying to get this on the file. You could have actual data that looked like this. Can you see that, Stephanie, down there?
Yes.
Right? And the lobe is pushed to one side. Okay, you want to guess, if there's right and left skew, what would we call this? Is this left or right skewed?
It's got to be left skewed, right? Because your data.
You want to guess the right answer? The reason I bring that up is it's largely counterintuitive, right? It's largely counterintuitive, but then when you understand what they're talking about, this is actually right skewed, right? It's kind of interesting. But the reason I bring it up is to try ironically, drive the irony of this is that in normal kind of thought process of what skew means, like it's skewed left, but what it's saying is the data got skewed way out here. That's where the skew comes from. Yeah, that's pulling the data. Yeah, that's why they call it right skewed. And obviously, if you go the other direction, it's left skewed. Right. It's again, these are things as you go along and you live in the community or environment of using this. You try to remember why things are. That's why I teach this way. Very practical. How it's not memorization, but it's remembering. Oh, okay, that's the definition of skew. The issue is that you have some data pulled way out. Right. So if your data was pulled in, this thing would start approaching ideal data. So I just wanted to bring up, you can end up with skew, which we're not going to worry about here. There are compensations for that. That'd be like the second level of statistics or operations, right? There are mathematical compensations that you can put there, and you can actually test whether it has much influence on the outcome anyway. Generally, if you have a mild skew, it doesn't really matter. It can be shown. Just got to get my eraser here. All right. Now, the other thing that can go amok with this is kurtosis, right? And all that is if this is your ideal, that's your ideal data. Kurtosis is some kind of weird flattening. It's not skewed, but it's flattened a little bit, or it has some kind of weird there's actually some like standard ways things end up with kurtosis in there, and it has like flat edges a little bit here. So you can get that. It's drifts from normal. In real life, you're going to get that. It's going to be how bad it is, or how close to ideal you're going to get. And some processes are just going to run skewed. Your motorcycle helmets at the end of the line might just be skewed left or right because of wherever the root cause of problems is, and that could be an indicator to you. You start seeing the data showing up on a graph on a computer screen, and you go, oh no, we got some right skew. I know where that's happening. After you had experience, you go, we didn't calibrate XYZ, or something happened. We didn't feed the little monster inside the machine, or whatever it is, right? Okay. All right. So the way that we use this, I'm going to go to Excel on this. So everybody's going to play along at home and play here. We'll get back in Excel again. And we'll do a few things around the data that explain how do we calculate this number. What happens is we have a formula that says give me any number in your curve, and I can tell you what percentage probability you're going to have, or what probability you're going to have of everything up to and including that. Right? Now you would think that we would want to know at that point, what's the probability at that point? For this application, we don't care about that. There's another function, very common one in Excel that you could use that say at a particular value, what's the property of it? But see, what we want to do is pick up what's the probability outside of acceptable to the customer on the low side. And as soon as we calculate that, we use symmetry and we multiply by 2 because the other side is symmetric to it. So just multiply by 2 quite often. There's another place when we use PERT. Did you do PERT in Dudley's course? We had a homework in here, I think, on it.
I know I read it in the econometrics book.
Yeah. So PERT is a way of program evaluation and bar technique. I can't think of the word right offhand right now. What happened was when there were really big programs with the government, then there were overruns. They started hammering this down, and all the companies had to get compliant and understand the process. And PERT, what it is let's change our thought process. I just want to change this out a little bit. We have these stacked processes, a whole line of processes here, and they're stochastic. There's an expected time out of them, and it could go shorter, it could go longer. We don't know. And when you take that into effect, that's what you use for PERT. And that was to correct some massive overruns on projects. There, we only use one side. We only use the answer. We don't multiply by 2 because what we look at is what's the probability of us getting a project finished up to a certain date. So we could get it done earlier, right? So everything to the left is viable or valid, right? Okay. Okay. So there we go. Let's do a little bit of Excel, okay? So I'm going to come back to my computer. You could jump into that file that you already have. Keep everything together. Okay, so let's just practice this a little bit. If you get into Excel, where's my Excel file? I got rid of it, didn't I? And now I can start projecting again. Okay. Let's shoot a picture of this. Because I'm going to erase it. Kick that on there. So if you're like me, the reason I shoot this and I'll make it available is It gives me visual cues as to where I was, right? You'll remember this class, and oh yeah, that was the part where he was talking about XYZ. So I don't like to just erase it and get rid of it. I think these are smart things you can actually print from, but I don't know how to use it yet. Okay. Okay. All right. So something that I want to show you, you might have used in your other courses, is in Excel, you can come in and come to, I'm going to throw options in here. Remember where this happens. Options. Add-ins. Okay, so in Excel, if you go to File and then go down to the bottom left and click Add-ins, I click Add-ins in here. Excel add-ins. This is showing me what I have loaded. I have the analysis tool pack, which is a statistical load-in for Excel that usually comes with it, with Excel. Have you used this before, anybody? Have you ever used this? Let me go through this again. Because I already have it loaded here, it's behaving differently for me. So if you go under File, you have like this left ribbon and go down to Options. In Options, then again on the vertical menu, there's add-ins. Hit add-ins. I want Excel add-ins. This shows up a little differently for me because I already have it loaded. All right. Because if I hit Go, it comes over and shows me I already have it. All right. So Analysis Tool Pack. All right. And this is how it's basically enabling it. It comes with Excel, but they try to leave it out because unless you're using it, it adds a burden on Excel, I think. Okay. And then what ends up happening is I think under Data, it shows up under Data. To the far right, you get the Data Analysis ribbon entry, and you click that. I'm going to show you some things that you can do here. We'll go forward and backward with this. Okay. So in Data Analysis, I am going to look for random numbers. I'm going to go to random number generator, okay? So if you take a look in here, there's a lot of things that you're going to use, say, in statistical process control that we won't go over here. We're not going to get too much further than we are right now. But you have t-tests, z-tests, and all these kinds of things. So random number generator, if you want to generate some normally distributed data, you can come in here and you can say, I'll take one variable and I'll take 100 numbers of that variable, okay? And the distribution, remember we talked about different distributions. In here we're going to go normal, but we have uniform, normal, Bernoulli, binomial, Poisson, pattern, discrete. Let's go normal. Okay, and then it says, what would we like the mean to be? Well, we're doing motorcycle helmets at 3.6 mean and a standard deviation. See, we're reversing the data. Okay, so I'm going to say standard deviation is going to be I don't know if you can do an equation in here, can you? Let you do this? No. I have to put, what's 3 into there? 6.66666. And then I want to tell it where I would want it to stack or store the data. So what you do is you click output range. You can put it in a new worksheet, a new workbook, or an output range. So I put my cursor in that little window there, and I'm just going to grab a cell like that. Okay. So we're going to end up with 100 numbers randomly generated as a normal distribution with a mean of 3.6. And we've been using the number 0.2 as plus or minus 0.2 are the spec limits from the customer. And I divided by 3 in my head. So what we're doing is we're putting standard deviation is 1/3 of that distance. So our 3 sigma is going to line up with those spec limits. I'll demonstrate by diagramming in a second here. Boom. All right. So these are the weights, the random weights that we just talked about. Now I'm going to format them. Notice that, there's not different numbers of digits here. Let's just make it easy on our eyes a little bit. Go back to the home menu item and format that just as a number. And let's go to 3 decimal places. Okay, so now that just standardized them. Okay. So what do you think if we calculate the standard deviation? What do you think it's going to come out to be? 3.6. Just want to make sure you're still with me. I know it's low calorie time right now. All right. Okay. So to go through this process, let's calculate the average, right? Okay. So we're going to come all the way down. In fact, before we do that, let's trim our data in. Let's clean up our data a bit. Let's give it an index number. This is just 0.1, 0.2. This is like reading 1 or sample 1, 2, 3, 4, 5 through 100. I'm just going to drag that down. Whoa. Come back up. Okay, so that's just our index. That's just the identity of that data point. There's 100 of them, okay? And then if you come all the way down, let's do the average down here. And I happen to know that Alt MUA is a shortcut. I use that often enough that I remember it. So we can hit the average. Hey, look at that. A little bit off because it's random numbers. It's not going to be precise. It's 3.603. Okay. Okay. So let's calculate the standard deviation from that. Okay. So for every point, we're going to find out how far away it is. The first, which I erased, but if you remember the equation, we're going to take every point and subtract the mean. Okay. So we'll start out with this is equal to our point of interest here minus, and I go grab the average way down here. So we grab that. And before I do anything else, I am going to use an absolute reference on that cell because we're going to use it a lot, right? We don't want that to auto increment. I'm just going to drag this down in a minute. So if you use the F4, if you use F4 on these computers in Excel, it will change that cell reference to absolute with the dollar signs in front of it. Okay, so that keeps it from auto-incrementing. All right, so I'm going to grab that, and I'm copying that formula all the way down to the 100th item. All right, okay. Remember what we said? What's the average distance to the mean at this point? Notice the negative numbers in there. What did I say about that? Alt MUA. What do you think it's going to be? 0. That's the issue because we have symmetric data. And even in randomly generated numbers that we have here, there's equal numbers of points on each side of the average. So because we have the negative in there, that's what's causing that problem. This is what caused us to start thinking a little bit more about this. So the next column, why don't we just take the square of that? Remember, we need to take the square of each of these. So this is going to be equal to that. Use a little caret sign. Where is that guy? Shift 6 to the 2. That's squaring it. All right. Drag that all the way down. All right. While I have that selected, I'm going to format that. Yeah. And just use like 5 decimal places. just so it looks good. So now they're all positive. It's that, but now they're kind of, it's getting away from us because they're squared, right? Okay, so what else do we have to do with this? We need to add all of those up. So I'm going to go all the way down to the bottom. And if you do Alt equals, that's a shortcut for adding those numbers up. So I added up all the squares. Remember the equation? Right? Added up all the squares there. Right? I'm just going to remember that guy. I'm remembering this, E103. In my case, it's E103. I don't want to have to come back down here and get it. All right, E103. Okay, so the standard deviation when we calculate it is going to be equal to E103 divided by N, which is 100. We're almost there. We divided by N. What's the last thing we have to do? Take the square root of that. You can use the square root formula on it, SQRT. Remember our average, 3.6? What did we tell it we wanted the standard deviation to be? 0.06666. All right. And the reason those are a little different is because it's random numbers. Not, it's real world, approximating real world. Okay? All right. Oh, I think I remember that if you just grab the numbers, you can do the standard deviation, right? So in Excel, they have the formula. You can just grab the standard deviation here. Let's do this. All right, so there's two formulas for standard deviation, one for population and one for sample. We're going to go as population here. So there's stdev.p, right? And I'm going to select all these numbers up here. All right, so we're just double checking our manual calculation there. I'm going to move that up near the manually calculated standard deviation. Exactly the same, okay? So that gives you confidence that you can use the primitive equations to get what's built in as formula in Excel. But we did it by understanding the process, right? Okay. I might be able to do this. Hold on a second. See if I can draw on here. Okay. Okay. So what we did is I'm drawing this as standard deviation. Just imagine that's nice and symmetric. All right. And what I did was all along we were saying that the user told us this is 3.6, lovely font, and this is plus 0.2, right? This is going to be 3.8. That's the upper limit is what they'll expect, and then they'll expect nothing below 3.4. Everybody follow? You okay, Stephanie? I mean, I'm trying to go nice and paced and stepwise here, okay? And what I did when I generated the information is I said, give me 3. This is why I divided by 3. Give me 3 standard deviations. Divide the 0.2 by 3. I reverse engineered this so it would come out right. So if our process, our control limit is 3 minus 3 standard deviation to plus 3 standard deviation, our ability at 3 and minus 3 matches up exactly with the goalposts. Okay? Right. And at some level, this is what a company might be striving for. You'll take better. You'll take better any day of the week, right? But minimally, our policy at the company said we can withstand, right? So what was left over after 99.7? Trying to drive this as clearly as possible. What's left after 99.7? That's our yield, okay? Our policy said, okay, the third year, we're willing to scrap 0.3%. So that means there's 0.15% over here and 0.15 over here. Capiche? Okay, right. So our capability is oscillating into and out of what we call capability, what the customer wants. Okay, so on a good day, our curve would be a little narrower, and our scrap would be even less because more things are built inside the goalposts. And on a bad day, the thing starts flattening out. We get some points way out here. Something happens, someone drops a wrench in the furnace or whatever, happens.
We call them self-firing because they just don't show up for
Yeah, that's right. Self-firing. Yeah. So we've pretty much seen the gist of how the core of this actually works. Let's go back to the Excel sheet. Okay. Okay. Okay, let's say, I'm going to move the numbers on us a little bit. Let's say that we have a bad day, and if you notice, this is where minus 3, I should draw that in a different color. Okay, Control Z. Okay. All right, so our real point of interest is that we decided as a policy for our company, plus and minus 3 is pretty good for most of our processes, our generic processes for most customers. We have a really picky customer that has tight needs, and we might have to go to what? We might have to squeeze 4 sigma between the goalposts. That means more of our production is between there. The policy for our company is what we're willing to scrap. So we're combining a lot of things: statistical process control, Six Sigma, which we'll kind of get into, and quality. Okay, so this has to do with quality and yield. Okay, because there's other things like there's utilization rate on your machines making T-shirts and things like that, and there's lean. Lean is generally what we talk about as very little scrap and very little inventory, building rate to order. Okay, all right. So what happens on a bad day if our process slips out a little bit, and really our 0.3 is here, I'm sorry, our minus 3 is here, our minus 2 is here, and our minus 1 is here. See, the whole thing, like a rubber band, starts sliding out a little bit. It maintains its shape. Okay. So what we would want to do is, what's the scrap on this day? This is what I want to get at right now before we leave here tonight. Okay. So we want to figure out what the area is now. The area increased because we got sloppy outcomes. Things started spreading out. If you see the curve spread out, that means we're losing things on either tail, right? So let's say this point went from 3 to now it's 2.5. Okay, this is what I want to talk about. Okay, so this is 2.5 down from the mean. Okay, so it's minus 2.5. Remember, we looked these things up in the table. We're going to look at z's. Okay. Our z that of interest is minus 2.5 standard deviation. Z is in the units of standard deviation. Okay. Out on our floor, we know we're measuring 3.6 as our average, right? Ugh. That's pretty bad, 3.6, right? Okay. So what ends up happening is we're gonna have more scrap. So we're gonna go back and we are going to use the inverse function, I think. Okay. Okay. First thing is we'll do something that we know. First we're going to do, hold on a second here. I want to make sure I get the formula right. Okay, here we go. So we're going to use the formula. We'll try to go with something easy first because we want to get at, remember that number 99.7? Let's go look that thing up, okay? So there's a function called norm.s.dist. What happens in Excel, you'll notice some of the functions get upgraded and some of them, what they call it, they get deprecated. They don't want you to use the deprecated ones. They're the older ones. And sometimes there's like a little yellow alert. You're getting into old territory. We've made things better for you. Norm.s.dist is the modern version of what we need here. So we're going to go and look at a number we already used. Then we'll look at minus 2.5. We want to look at minus 3, something we already know about. So the z, the number of standard deviations, is minus 3. And I always have to remember which one this goes. I think we want a 1 there, okay, or true, right? Okay, so this function behaves two different ways, and you throw a flag, so to speak. Okay, so you put comma, and then you tell it which way you want it to work. Let me see, true's cumulative, probably, yeah. I think that's what we want. You want to throw true in there, yeah. Okay. So what? That's the probability. What's the percent probability? If we multiply that by 100. What does it come out to be? 0.135, okay? So we were estimating 99.7 before, remember? We're a little bit off on that estimate, all right? So what that is if we have a normal distribution like this, what we just looked at, we're looking at the point minus 3 standard deviation, and we're looking at the area of scrap, okay? For discussion purposes in most manufacturing circles, as I said, plus or minus 3 is sort of a starting point with that. That's why it's going to be very common in problems. Sometimes you're going to see minus 2 to plus 2 or minus 4 to plus 4, right? So what we just calculated was the area down here was 0.135%. And because this is symmetric, I'm trying as best I can to write with my finger here. Usually I have my digital pad. So 0.135 here, we multiply that by 2 and subtract that area from 100, okay? Okay, so we're going to actually get a closer number on a 99.7. So this is going to be equal to two of these tails. Yeah, we have to account for 2 of the tails. We just lost things beyond what the customer wanted. And before, when we said 99.7, we meant to say 99.73. Okay, so that's a more precise number. Okay, so we have control over what we're talking about here. We can go to Excel, and even though we remember the empirical numbers, we call them, for the plus and minus 1 and 2 and 3, we want to have the capability in Excel. That's why I'm going through this with you, is because usually shop floor management software systems will do all this for you, but you want to know what's really going on under the covers, and it will actually explain some other behaviors later on. Okay. Okay, so then we had this bad day. What did our scrap go to? So we'll run this function again. I'm lazy, so I'm going to drag it over here. And all I'm going to do is change it from minus 3. We want to calculate it for minus 2.5. Nope, I missed the decimal point. Right. Okay. So you've got to remember the shape. Okay, as you go out on the edges, it's become so slim that now, as you move units of standard deviation, it's a diminishing return or opposite, as it starts encroaching back into the middle again, you're beginning to get a bigger, bigger bite because of the shape of the curve. You're getting bigger, bigger area for every unit move you make on the x-axis. Right? So we need to multiply that by 2. So I think if we just copy this over, it's going to behave well. Oh, I know what I did. So this is going to be, as you would expect, 0.6. I'm just going to go with 0.62062%. What's going on there? Oh, that's right. It went up. Yeah. I forgot. Okay. The way that we did this is we said one-sided, that's 0.62%. The probability is 0.000 or 0.006209655. So we're going to do the same thing. Where it's from 100%, we're going to subtract 2 of those. Okay. And so our yield dropped by about 1%. That's what you end up doing now is playing with different numbers that occur on the different parts of that curve. And you're going to notice where depending on where you are on the normal distribution curve, as you kind of dither around a certain point, that the amount of area for a unit move on the x-axis is going to go up or down. Right. So you see what happened is we got looser and our yield went down. By losing a half of a standard deviation, we lost 1%. A half of standard deviation change gives us that. Okay. And what we left out was sort of the middle explanation. Okay. All right. Well, I think that's good. We're at. Okay. So basically, when we go to this drawing, what we're saying is where it ended up on our daily performance level, the goalpost ended up at a point that was equivalent to minus 2.5 standard deviations down. Okay. What we left out, and that I'll do now, is how do we move from native units into these Z's? This is a Z, okay? So let me page down a little bit here. Keep that in mind. We're not going to leave that too far behind. Okay. I'm getting messages from GoToMeeting here. This isn't updating. Yeah, something goofy's going on. GoToMeeting's interfering with OneNote. All right. Okay. So the middle explanation is this. When we have the normal distribution as such, consider that perfect data. I can't draw too quickly with my finger here. There's our goalposts. Okay. We have a 3.6. Mean. So suppose that the customer said, guess what, we're changing our acceptance criteria, all right? We've got to go closer. Our customers are getting a little bit choppy about this. They want us to have tighter weight tolerance on these final weight tolerance on these helmets here. Okay, so instead of -2 and +2, they're going to go down 0.2 rather. We're going to go down minus 1.5 to plus 1.5. So they narrowed the goalposts, right? And again, I said it the wrong way. It should be 0.15 and so it's 0.15 to minus 1.5. So it used to be minus 2 to plus 2. All right. Okay. All right. Everybody tracking? Everybody's doing okay? Let me go back to the camera here. I want to get at the Z transform, and I'm trying to set this up so that it works. I don't have the numbers offhand that make this thing work. All right. Let me explain it first. Where'd the camera go? I lost the camera somewhere around here. Go to meeting. How do we get it? Come back here again. It's supposed to be on my desktop, and I don't find it. Okay. Technology. I minimized it, but it's not popping back up again. I heard that yawn. Hang in there for a few more calories, all right? It went away. How do I show it again? Oh boy. Webcam. Yeah. All right, I'm sorry about that. It's like the technology's hung. I don't see where the audience. What the? All right, this is gonna be a problem. Let me try to do it a different way. Okay, I just want to get through one part. I'm sorry, it's laboring out on this. It's stuck. All right. Okay. So we know in our data that we used 2 divided by 0.2 divided by 0.06. Okay, so we used our standard deviation was 0.066. Okay. I'm going to go to the more general approach to this. We're just talking statistics now. All right. So here's our data of motorcycle helmet weights. And what we have is 3.6. All right. 3.6 is our average. It's meaningful to what I need to describe here. We're almost through. I'm sorry that this kind of got beleaguered, got put under here. All right. So 3.6 is our average. And what we want to know is what's the probability that our motorcycle helmets would weigh up to and including some number over here, okay? So let's use let me think about how to do this, 5. Does that work? 9. It goes down from 3.6 pounds to 3.4 pounds. So let's make this 3.58. Okay, this is just a statistic technique that we're using under the covers, and I just want to bring it back up to the level that is visible again. Okay, that is just horrible. That's supposed to say 3.58. Okay, hang in there with me just a few minutes longer here. 3.58. Okay, so what the question is, within what we're talking about here, we're interested in what is the area up to and including 3.58, or in production terms, we're going to say what is the probability that we're going to have a motorcycle helmet that the one that we pick off doesn't exceed 3.58 pounds. What's the probability of that? Okay. Looking at the symmetric curve to begin with, in what range do we think the probability is going to be? What's the probability of getting a motorcycle helmet that does not exceed 3.6 pounds? Can you get that, Ludwig? We're looking at, what is this mark? Your average on perfect data, right down the middle, okay, marks what? The middle, right? Okay. So what's the probability a motorcycle helmet will not exceed 3.6 pounds? It's going to be down here. I want to make sure you have a working feel for what we're talking about as we go through this problem. What's the area to the left of the middle point? What's the probability of half of the curve? I think we hit the wall. 50%. I know you know this. It's 50%. Okay. Kind of lost a little bit of momentum here. Sorry about that. Technology. Okay. So 50%, the probability that it will not exceed 3.6 pounds is down here. And the reason I use that is if you pick up on the language of this probability, the more I use it, the more you'll just get comfortable with what's going on in here. Pick the words carefully. Probability that it won't exceed 3.6. What's the probability that it will be over 3.6? 50%. Good. Yeah. Yep. Trying to regain a little momentum here in our thought, get our brain cells back online here. So yeah, 50% on each side of there. So now we're going to say just a skosh less than 3.6 pounds, okay, is 3.58. What's the probability? What's the number of helmets that we produce that are going to be under 3.58? Or what's the probability that a helmet that we pick off won't exceed 3.58? Right, and I was trying to get it. What we want to do is get a working feel that we understand what's going on. It's a little bit less, okay. Where I drew it it should be probably very, very, very close to this, right? Because the user spec on this is somewhat over here, and we said it was 0.2 down, right? So this number is going to be pretty close to 50%. How did we actually calculate it? That's all I was trying to get out of this. Technology just put a burp into the continuity here. But okay, so how do we do that? It's the same problem, but we need to be speaking in terms of standard deviation, right?
Is it average minus sample X over standard deviation divided by
square root of n?
There's no square root in this. It bears a little bit of similarity, okay? Yeah. So, see if I can finger paint this thing a little bit better. Okay. Okay. Yeah, this is okay. This is a Z. Don't freak out over the Z. What is a Z? A Z is it looks kind of similar to what we were doing before. We're going to take a point of interest and I'm going to use the letter I. So there's some point of interest, 3.58 in our case, and we're going to look at how far it is away from the standard deviation. So now, I'm sorry, from the average, okay? So we're going to see, now we're just looking at 1 point. Before we took the average distance to the mean of 100 points. Now we have a specific point. We want to figure out what the probability is. And we have this function that we've already used. I'm creating the middleware here that we didn't look at, okay? So when you have a point of interest of 3.58 here, right? Subtract 3.6 and you're going to get minus point, what is that, 0.02? All right, okay. We're going to divide that. In fact, I don't want to use those words. We're going to compare the distance of that point, how far it is from the mean, to the standard deviation. How many standard deviations? If you have a IndyCar race or NASCAR race, oh, they won by 4 car lengths. Well, that's because the cars are pretty much standard there, right? So now we have this thing we call the standard deviation, average distance to the mean of all the points, right? And what we're going to do is we're going to compare how far away the point of interest is in terms of standard deviation. What does that give us? This gives us the standardization that somebody doing microbes work up in the top of Aquinas Hall up here in a petri dish up in the science building up there, floor up there. And we're doing operations and another group is doing weather data. We convert from native units to how many standard deviations away from the mean are we, okay? So this comes out to 0.02, right? And we compare that, i.e. we divide by how many standard deviations do we have there, okay? So I'm going to run over to here, and I'm going to type in minus, or is equal to 3.58 minus 3.6, okay? And we're going to divide that, and we have the cells somewhere here. We're going to divide by our standard deviation, which we calculated 2 different ways. Take your pick, right? All right, so now we're going to talk about that distance and how, in terms of how many standard deviations it is. It's just a 0.3 of a standard deviation. Standard deviation was 0.06 pounds. But now we have a unitless number. It's just a ratio. So it's a unitless number. And this is what we normally take to the tables, right? So if you go to the internet, if one were to go to the internet, right, and you go here and you look up, I don't really need that. If I look up the Z table, okay, so you can find a tabulated version of it, or you can use Excel to calculate it. And I go under images. Just give me an image here, and I grab one of these. Okay, so here's a typical Z table, and we're going to be looking for, of course it gets complicated all of a sudden. What do they want to do here? Here it is. Okay, so negative score table, and what was our number? It was minus 0.3 standard deviations. So we go down to minus 0.305. So actually it's just, we're going to use this number here, 0.30. We could go round up to 0.31 to make it interesting. Okay, so we're going to use this number here. All right, 0.31. Okay, so what is that number that comes from the table? What is 0.37828? You can kind of look at the table and get a gist of what's going on under Z.
Oh, it's the probability.
Yes, right. It's just a probability. I'm just trying to make the synapses connect here, right? So what's the probability that a helmet won't exceed 3.58 pounds? It is 37.828%.
A little bit. Definitely under half.
Mm-hmm. Yep. Yep. Okay. Yep. All right. So that's what the Z is. Okay. Okay. We'll leave it at that. I don't think we could possibly go longer. Did everybody hit the wall? Yeah, I'm sorry about that. I lost a little of your continuity there with some technology stuff. So the Knicks at home, hopefully you caught all that. I think that the visual on this was recorded better tonight. And a lot of this is preparing for next week so that next week there'll be more people playing at home here using this technology. Now, in the next 24 hours, I'll issue information about quizzes. If you have questions about how to complete, I'll issue the instructions and rubrics for the paper. All right. Anything else? A couple videos. I have videos about this. Okay. And what this is driving us toward is, which chapter is it? Okay. So let's take a look at the homeworks. This is what I'm talking about here. Make sure you're getting all your Learn Smarts and homeworks done. And
So just to clarify, we're not coming here, we're gonna
I already did send out a go to meeting invitation. Yeah. All right. And then chapter 9, quality control. Yeah, it looks like chapter 10 is statistical process control and such. And what we're doing here is core to that. We'll follow up with the PC and X-bar charts next week. Okay, that we just take what we have now and we understand what those look like. Okay, thanks a lot. Thanks for playing at home, guys, if you're still there. Looks like you still are. Okay. All right. Bye, Stephanie. So Nick M, if you could just shoot me an email about what didn't exactly work there with the connection. Maybe it was a moving around and whatever, or was the first half better than the second half or whatever. The second half I changed mics too, so maybe there's something with that. All right. So if you could just shoot me an email, actually if both of the Nicks, you can just send me some thoughts about what worked and didn't. That would be very helpful. Any questions too? Let me know. All right, people, have a good night. All right. Bye now. Bye everybody out there, and go to meeting land too. I'm going to fold this up.